Do you know that the total mass of a rocket launched from Earth is 95% fuel? Millions of dollars are wasted on fuel just to get something into orbit. Scientists are scrambling for answers just to make space exploration economically viable. The United States might have found the answer: a way to store fuel in space. Imagine a storage in space, full of rocket fuel just like a gas station in space, where rockets can easily stop by and fuel up, creating a massive opportunity and flexibility for space exploration. But how will the United States create such a fuel reserve in space? Is the United States going to use this to cement its superiority in space? And how does this relate to a precious material on the moon that even other countries are racing to get? In today's video, we are going to unravel how the US is planning to put fuel reserves in space. The imminent fuel problem of space explorations. As I said earlier, 95% of a rocket launched from Earth is just fuel to lift payloads outside Earth's orbit. That means only 5% of the rocket consists of components and the payload itself. We are wasting millions of tons of fuel just to put something in space. And it is holding back our progress to further explore space because it is way too expensive. Let's look at an example. On average, rocket boosters consume a staggering 11,000 pounds, 5,000 kilograms of fuel per second. That is 2 million times the rate at which an average family car burns fuel. Remember that this fuel is a non-renewable source of energy. We are spending this much fuel every time we send something into space. In the 1967 Apollo mission to the moon, the rocket used, the Saturn V, used almost 500,000 gallons of fuel just to leave the atmosphere. And it burned up almost 1,000,000 gallons of fuel to reach the moon. The giant leap of mankind comes at an overwhelming cost. Scientists at NASA are very much aware of this problem. Actually, this is their #1 priority as of today: reducing the cost of space exploration as much as possible, and it makes a lot of sense to start with the consumption of fuel. The wealthiest man in the world, Elon Musk, is also presenting different ways to reduce fuel consumption with his private space company, SpaceX. SpaceX is now a leading space company and has a direct relationship with NASA, and together they are promoting more efficient ways of launching rockets into space. SpaceX's latest rocket, the Starship, is projected to use only 26,000 gallons of fuel. That is almost 20 times lower than the average fuel consumption of NASA's rockets. Even with this lower fuel consumption, it is still higher than the number we need to become economically efficient in terms of space exploration. It might sound strange, but the moon might have the answers we need. Different countries are aiming to mine a precious material on the moon. The US might need to hurry up because competition is getting a little tight. The exciting part of this is that a fuel reserve in space might be here soon. This precious material on the moon everyone is chasing. A giant leap for mankind? In 1969, American astronauts Neil Armstrong and Edwin Aldrin became the first humans ever to land on the moon, making their way into the history books. Now, maybe you are wondering, why did we suddenly stop going to the moon? The first reason is that the public's enthusiasm about the moon declined considerably after the successful Apollo missions. And the second reason? Money. The Apollo missions cost a lot, and with the public's interest fading, it was hard to justify the staggering amount per mission to the moon. Now, 50 years later, the race to the moon is once again raging. Still with high costs, but this time the moon is offering something in return: an expensive material that every country wants their hands on. In 2008, India's space agency launched the Chandrayaan-1 into lunar orbit. Just another regular mission to the moon. But this mission found a very precious material on the moon: the first definitive discovery of lunar water. Scientists have long suspected that water might exist on the moon, but not until India's mission in 2008, when they confirmed the presence of water on the surface of the moon. Well, the next question is, how much water does the moon have? It is more prominent than you think. The moon harbors almost 1.3 trillion pounds, 600 billion kilograms, of water ice, enough to fill 240,000 Olympic-sized swimming pools. But this is only a rough estimation. Scientists believe that the number might increase by 10 to 20%. Maybe you were wondering, so what? Why is this lunar water so important? How can we use this to create a propellant reserve in space? How can we store fuel in space using moon ice? Imagine a place in space where we can just stop by and refuel our rockets, just like a car refueling in a gas station. Well, the United States can create one of these gas stations in space. But what is this strategic fuel reserve anyway? How exactly can we create one of these in space? In research led by American aerospace engineer Troy Bruno, the Strategic Propellant Reserve will be modeled after the Strategic Petroleum Reserve set up by the US government in the 1970s during the oil crisis. The Strategic Reserve back then had enough oil to sustain the US economy for 90 days. Bruno is proposing to have a reserve in space that can fuel space rockets for 2 years. He also predicted that a $30 billion investment in this fuel reserve could profit the US by up to $3 trillion by 2050. But they need one thing to make this into reality: moon ice. Now, the remaining question is, why would we need moon ice to make this space fuel reserve a reality? Well, it is just simple rocket science. Water is made up of what? Hydrogen and oxygen. And these two elements are the building blocks of rocket fuel. With these materials closer to the moon, refueling using Luna-based fuel can be done much more efficiently and could also support millions of years of space exploration. According to Bruno, we just need an infrastructure on the moon to mine this moon ice and convert it into a fuel. We can create fuel on the moon, and we can transport it inside the fuel reserve near the Luna surface using Luna water. Let's say this fuel reserve in space would be made. How can the United States benefit from this? Is it true that they can profit by almost $3 billion by 2050? Can the United States keep its space superiority with this? Have you ever heard of a cislunar economy? Cislunar is the area of space between the Earth and the Moon. And believe me when I tell you that this area in space holds an unimaginable amount of fortune waiting to be grabbed. In Troy Bruno's words, there is tremendous wealth and abundance that literally defies human imagination. Between the Earth and the Moon are numerous asteroids with precious raw materials inside. Combining them all, we can get 1,000 years worth of Earth's annual production of precious metals such as gold, silver, and platinum. If the United States has fuel reserves in space, it will be much easier to refuel rockets in space and navigate towards these asteroids in no time. The cislunar economy will thrive dramatically and will move the US to insurmountable heights in the space industry. Imagine harvesting millions of dollars worth of raw materials in space. Not just that, it can also cut the cost of space exploration. Reaping valuable metals in space sure sounds nice, but what's even more exciting is that we can easily transport people to Mars at absurdly low costs. We can refuel rockets using the fuel reserve and transport people to Mars. Scientists predicted that with this, we might have an outpost ready on Mars as soon as 2045. The United States better be hurrying, because they are not the only country hungry for that Luna ice. We might be at the start of another space race.